I'm going to talk about RAM, which stands for random access memory or the main memory of the computer, and their different types. The RAM or the main memory is a very important component in a computer. So what happens is your central processing unit, your microprocessor or the CPU fetches code and data from this RAM for the program being currently executed by you. Let us say you have written 20 programs and currently you are executing program number 1. Only that program which is being currently executed by you, executed in the sense being run by you, is going to reside in the RAM. Now, what is going to happen is during programming, there will be certain intermediate calculation or intermediate results. These intermediate calculations or results are also going to be stored in RAM and it's going to be read back. The interesting thing or the characteristic property of the RAM is it is volatile in the sense as long as the power supply is there, you can read and write from this random access memory. The minute you switch off the power supply, all the data and program is lost from the RAM. RAM is very small compared to your hard disk or secondary storage or auxiliary storage. For example, if the size of your RAM is 4 GB, 8 gigabytes, 16 or 32 gigabytes, your hard disk will be about at least half a terabyte, which is 500 GB or 1000 GB. Now, just as houses have addresses, every location in the main memory has something called as a unique address. So your memory is divided into a number of bytes. Each of that byte has a unique memory address. Now we shall now discuss the different types of RAM. The first type of RAM I'm going to discuss is something called as the Edo Ram, which stands for Extended Data Out RAM. This RAM or random access memory is no longer used. It is an old type of main memory which was primarily used in the early 90s to increase the reading speeds from the main memory so that the CPU can process faster in special processors like the Intel Pentium processor. So Intel Pentium processor, if you wanted the reading to happen faster, you tended to use the extended data out RAM or the EDO RAM. Now, the drawback of this was the complete circuits had to be redesigned or special design had to be done in order to take advantage of the features of this EDO RAM. So because of this drawback, it's now been replaced with either an SRAM or a DD RAM, which we shall be taking a look at. So the first we shall take a look at is something called as the SRAM. SRAM stands for static RAM. Alright, so this is your static RAM. Let's try to understand what is your SRAM. So SRAM is also a type of main memory. Okay, main memory, this is an example of how your main memory is going to look. So SRAM stands for static random access memory. You will understand the reason why it is called static in the next couple of minutes. It is a type of RAM. It is volatile because once you switch off the power, all contents are going to be lost. It uses a circuit called as a flip-flop or a latch. A flip-flop or a latch is an electronic circuit which is used to hold one bit of data, one bit. So it can either hold a 0 or 1. So using millions of these flip-flops or latches, you can store data into this SRAM. The advantage of SRAM is its speed is much higher compared to the dynamic random access memory we are going to talk about in the next slide. But the drawback is it is very expensive compared to the DRAM, and it is used in high speed requirements like the cache memory of a computer. You will understand about what is a cache memory in the last session of this particular lesson. All right. So this is a static random access memory which I have given you a brief idea. Now let's try to take a look at the DD RAM, the double dynamic rate synchronous dynamic RAM. So this is again a type of main memory. You can see this chip here. Here ones and zeros were stored using flip-flops. Here ones and zeros are stored using capacitor. The logic is simple. If the capacitor has a charge, that means it is 1. If the capacitor has no charge, that means you can consider it to be a value 0. But the problem with capacitors is they lose charge very frequently. So they require special circuitry to refresh those capacitors. Alright. So most of the main memory in today's machines happens to be your DDRAM, or the double data rate synchronous DRAM. Alright. So this is the memory which is going to be used in your computer. Now the current DDRAM is DDRAM 5 is what you're going to get, or the latest version of this memory. Every version DDRAM 1, 2, 3, 4, 5, the higher the number is going to increase better performance or faster read and write into this. This is comparatively cheaper to this particular fellow, and this is extensively used as the main memory. So when I talk about RAM, I'm invariably talking about the DDRAM.